Welcome back. In this third instructional video, we dive into the field of sex estimation. We will talk about how we can estimate if someone was a male or a female based upon the appearance of their skeleton. A few quick definitions before we dive into it about the difference between sex and gender. We will speak about sex estimation and not gender estimation because these are two different things, and in almost all cases we cannot determine what someone's gender was. So sex refers to the physical aspects of a person determined by their chromosomes, XX for female, XY for male, whereas gender describes the characteristics that a society or culture assigns to masculine or feminine behavior. Hence, one can be biologically female but have a gender that is masculine, or vice versa. But all that we can see from the skeleton is someone's sex. The levels of the two main sex hormones, estrogen, which is higher in females, and testosterone or androgen, which is higher in males, begin to markedly differ during puberty, and as we know, cause differences in male and female secondary sexual characteristics. Some of the differing secondary sexual characteristics result in changes to the underlying skeleton, and these are the basis of our sex estimation methods. For example, once puberty hits, there's an increase in the size and mass of muscles and bones in males. However, in females, there's a widening of the pelvis. The onset and completion of puberty will vary somewhat between population based upon factors such as nutrition and health, but in all populations it's usually almost complete by late adolescence, so around 18 or so years of age. And it's for this reason that we usually only estimate the sex of adults. In subadults younger than 18 years, the differences between the skeletons of boys and girls are too small to provide accurate sex estimations. In the rest of this video, we will show you some of the features we use to estimate the sex of a skeleton based upon three areas: the cranium, the jawbone called the mandible, and the pelvis. We will not have time to show you all of the features that can be used. Rather, we will focus on those that are most commonly used and easily identified. So let's begin with the cranium. The male skull is typically more robust with more pronounced muscle markings compared to the female skull, which is more gracile. And this manifests itself in a few ways that you can feel on your own skull. First, there's a ridge of bone above your eyes called your brow ridges or supraorbital ridge. Feel your own. In males, this is usually larger, sometimes forming a bit of an overhang above the eyes. And in females, it's usually smaller, sometimes completely absent. Does yours correspond to your sex? It may not, and that is completely normal, something we will come back to later. Next. Feel around to the back of your cranium for a bump in the middle, close to the top of your neck. This bump is called the external occipital protuberance. It's typically larger in males than it is in females. You can sometimes see it clearly as a distinct bump on men with shaved heads. In some females, it's difficult to find the location of the external occipital protuberance because it's not raised at all, but rather entirely flat. Next, move to feel the bump of bone immediately behind your ears, called the mastoid process. Males usually have broader and longer mastoid processes than females. And there are many other features as well, including the slope of your forehead. Males usually have more sloping foreheads than females. The shape of your eye orbits, the shape and robusticity of your cheekbones, your zygomatic bones, and additional features that are harder to observe on yourself because they're covered by muscle and skin. Now, in conducting this short exercise, did you notice that even within your own skull, some features appeared to strongly match your sex and others did not? Many of you will have found this. All of the features we've shown you exist on a continuum, from very typically male or female, two in between, and no single feature ever corresponds to sex in 100% of all cases. A skull that is very male-looking mastoid processes and brow ridges can have a very female-looking external occipital protuberance. So it's of the utmost importance that as many features as possible are observed, and more so that we use a categorization system that reflects this gradation in trait morphology. Typically, osteoarchaeologists will score traits according to a 5-stage system, as shown here. 5 means the trait has a very masculine appearance. 4 is it's a moderately male appearance. 3 is in the middle, and it's indeterminate in regards to male versus female. 2 has an appearance that is towards the female end of the range, where 1 has a very female appearance. And by scoring as many traits as possible on a scale such as this, we can achieve upwards of 80% accuracy in sexing the cranium. But in every population, there always will be instances of males and females who have the sexual characteristics of the other sex. Finally, the sex obtained from one part of the body does not always agree with the sex estimate obtained from another area of the body. In such cases, we put the most weight on the result from the area of the body with the highest amount of consistent differences, which is the pelvis. There are a few traits in your mandible that can vary between males and females. Males usually have a larger and more robust mandible than females. Now I'll show you a few of these traits. First, palpate this area of your chin. Feel the shape made by the outline of the bone. In males, this area is usually more squared off and thus flattens, while in females, this area is usually more rounded. Second, feel the bone at the back of your jaw, the part that comes down from the joint made between your jaw and the cranium. In females, this usually occurs at a more obtuse or wider angle. In males, this usually occurs at a more acute or narrower angle. Also, at the tip of this part of the mandible, at a point called the gonial angle, there is sometimes a sex difference, with males often having something called gonial eversion. This point becomes slightly flared outwards, almost as if someone grabbed this bit of bone and pulled it outwards. Females usually lack this characteristic. Bear in mind that there are other traits that can be considered, but we will not review. Now, onto the pelvis, or os coxa. This part of the skeleton is by far the most accurate for sex estimation. It usually shows rather pronounced sex differences related to females needing to undergo pregnancy and childbirth. With well-preserved ossa coxae, in which many traits can be scored, we can achieve an accuracy of greater than 90%. Let's begin with the front of the pelvis, in the area where the 2 pubic bones meet. In the last video, this area was used for age estimation. Now we're interested in the angle that is created beneath the junction of the 2 bones, called the subpubic angle. So a female pelvis needs to be wider to accommodate childbirth, and this is one of the areas where this difference can really be seen. A female will typically have a much wider subpubic angle than a male. And there are also other differences that occur in this area. One can think of how this widening of the female pelvis is achieved by imagining that it's almost like someone took the 2 front pieces and stretched them out. In doing so, not only does the subpubic angle increase, but so too does the width of the pubic bone, wider in females, and the appearance of the pubic bone with an arc, ridges, and concavities being created. These last 3 characteristics are known as the Fennis traits, after the researcher who discovered and published their use in 1969. and Christine will explain and show you more about them in a short optional video located in the course documents. In thinking of the pelvis as wider in females to accommodate pregnancy and childbirth, where else might we see this? Well, also in the overall width of the pelvis as a whole, in the orientation of the pelvic blades being more angled or flared in females and more vertical in males, in the shape and size of the pelvic inlet and outlet, again wider in females than in males. There's a commonly observed trait called the greater sciatic notch. This, again, is typically wider in females than in males. And here you can see the gradations of that trait on a 5-point scale from very female to very male. Now, let's look at some of the changes towards the back of the pelvis and also in the bone that connects the two halves of the os coxa at the back, called the sacrum. Just as the front was stretched out in females, so is the back. And this manifests in a raised auricular surface, almost as if someone put a suction cup on the auricular surface and pulled it out. And also this can cause a groove or a furrow to form underneath the inferior edge of the auricular surface called the pre-auricular sulcus. Finally, females typically have a wider sacrum that is straighter and projects less into the pelvic outlet than the male sacrum. Obviously, during childbirth, one does not want the pointy end of the sacrum, the coccyx, sticking into what is already a tight space. In fact, the coccyx is a bone that is often injured or even fractured during childbirth. It is important to mention that other bones can be useful in sex estimation. Males are usually taller than females, and therefore we can use the size as well as the robusticity of long bones to estimate sex. The foot bones too can be useful, as men often have bigger feet than women. And in fact, most bones in the body have been studied to determine the extent of differences that can occur between males and females. This is especially important in archaeology because sometimes we only have a few bones to work with. In this video, we've learned about many of the traits human osteoarchaeologists use to estimate the sex of an adult skeleton. You've become familiar with traits on the cranium, mandible, pelvis, and sacrum. Also, you've experienced why it is important to score as many traits as possible from as many key bones as possible, and to do so on a graded scale. In the online discussion forum, we're asking you to comment upon why or why not you think an osteoarchaeologist would correctly sex your skeleton. What factors might cause inaccuracy in our methods? Also, remember the ever-important point that it is crucial to use population-specific standards as much as possible. In the next video, we will explore the methods used to reconstruct the stature, the height of someone based upon their skeleton. We will learn why people are taller today than ever before and when that process started.